The Apollo mission, that's where they had the explosion, Apollo 13. If you ever watched Apollo 13, it's because they had too much of the gas and they had a leak. And when they tried to get to where they produced energy and stirred the tanks, I guess, that's where they had a spark and they had an explosion. And they lost all their energy because they lost all their hydrogen and oxygen gas, or a lot of it. And that was their life support. Okay? So what we're going to do is we're going to make split water into hydrogen and oxygen gas. That's an example. Do you guys have the graph, right, for the energy diagram? Okay. This is an exothermic. Is what we're going to do is the example is combustion of hydrogen and oxygen gas. So the example is combustion of hydrogen and oxygen gas. That's the example on the exothermic side. So that is the opposite. Okay? So we would have the opposite happening. So we're going to do this in a balloon. We're going to do it one more time. We're going to take H2 plus O2, and we're going to get H2O. Okay? Austin, you have a note?
No, I forgot to ask one.
Okay. Where were you at? Okay. So this would be the reaction of combustion. So it's the opposite. Instead of splitting them, it's bringing them together to make water. So we're going to take hydrogen and oxygen gas and we're going to put them together to form water. Okay, is there anything else on that backside you need notes on? No? Okay, does everybody have the joules that they've got written down? What I'd like you to do, just to make it easier on me, I would like you to make a 6 column to the right. Looks like this. 6 column, and then I'd like you to write your joules of energy that you should have calculated on Friday. So make that 6 column. I think yours is over there. Awesome.
Probably.
Make that 6 column. And write in your joules of energy you calculated for each one of those. When you have that done, I will collect that. And I'll look to grade that.
Was that this one for you?
Yep. Okay, so number 1 on the sheet, on the lab, it asks you to find the mass of the water that's being heated. So we're always going to measure heat transfer by using water. It's a very good way in which to measure how much energy something's given up, by measuring the water increase in temperature. Okay? But one of the things we need to know is how much water we have. If we have a lot of water, it's not going to raise a lot in temperature. We have a little bit, maybe more. So there's this idea, if we have 100 milliliters, which I told you had to fill 100 milliliters up, that we need to find out how many grams that would be of water. Now you guys know how many grams it is, right? 100. Now that doesn't work with, that only works with water, where they're the same. Okay? So they're the same because of this reason. So this is a reason. If you take 100 milliliters and convert it into grams, you need to know the density. So you guys remember that density equation? It said density equals mass over volume. Remember that? If I want to find the mass of water, what do I have to do? I have to take density times volume, right? So density times volume equals mass. So I can set it up this way, and I can put milliliters down here, and here I can put grams. And then what I do is I say for every 1 gram, I have 1 milliliters, because the density of water is 1 gram per milliliter. And it seems a little silly that I'm showing you the steps because it's the same ratio, but there'll be some that will be a different ratio. I'll give you an example. You don't have to write it down. Okay? I just want to give you an example where it's not this simple. Okay? So don't write this down, this one. Okay? And I want you to tell me how many grams I would have of ethanol if I heated ethanol up instead. Okay? Again, don't write this down. So let's say I have 100 milliliters of ethanol. Okay? And ethanol's density is 0.78 grams per milliliter. So I would do the same thing. I'd put 100 milliliters out in front. And then what I would do is the same thing. What unit goes down here? Milliliters. Up above goes grams, right? Milliliters cancel out. So what numbers go in those two spots? What goes in front of milliliters? 1 per 1. It's always the bottom one's always going to be 1. And then up above I put 0.78 grams. So how many grams do I have? 78. So it doesn't always, water is nice because it's the same ratio, 1 to 1. But here's a case where it's not. So there might be a time in the future where you have to do a conversion to actually figure out how many grams you have. Okay? Alright. Alright, good. Number two. Number 2 is asking you to determine the change in temperature. I don't think I need to go through that example, but just go ahead and calculate the change in temperature and show it. So like my sample, let's say it started out at 5 degrees, and it went up to 8. Then that's a change of 3 degrees. So I go 8 degrees Celsius minus 5 degrees Celsius. My degree change is 3 degrees. Okay, so calculate your change in temperature. Now, I probably want to be detailed because if I look at this and I just have an answer, that might not be as helpful as having everything just shown. Okay? Because this again is your notes for a quiz that you can have. Alright, the next one you've already done, and it's the heat transfer. Okay, so the next one you've already done, but it's heat transfer. So what you're doing on 3 is you're going to use this equation here. Joules is equal to change in temperature of the water. Okay, and then it's going to be the 4.184. And then that's a specific heat. And then it's going to be mass of water, which we figured in number 1. So go ahead and calculate your joules. I want to see it. Just show it, calculate it, and then we'll go down to number 4. Show that setup too, because that'll help you on the quiz. If you have all that written out, then you know specifically what you're plugging in. So show that setup there. Mass of water. So on number 2, you have to change the temperature. The 4.184 is just a number we always use with water. It tells us how much heat is gained when we have a certain temperature change, a certain weight we have. And the mass of water is the answer for number 1. So We should be getting a number in the thousands, right? And the value is joules. J for joules. Okay. Number 4. Now this is a different weight. We've already figured the weight of water. Now this is the weight of the fuel that we're burning. And so we need to look up the weight of the candle before and afterwards. And then we need to make sure we subtract it. So let's say the weight of my candle was before was 8.13 grams. And then afterwards it weighed 8 grams. So I'm going to take 8.13 minus 8. And the weight of my candle that changed is 0.13 grams. That could be an example. I don't know what your numbers are, but you're going to put your numbers down there. Okay? So this is weight before, weight after, and it's going to be 0.13 grams. If you want to write in there before and after, that might help you so that you have that information. So any notes that you can put down that you think might be helpful in doing a problem similar to this can really help you out doing it right. Getting it right each step. Do you guys have about in the tenths, your change? Because that's what I noticed in the other groups. So. You may have more or less. Okay. So we got all our information to figure out the heat of combustion. So if you turn your page over and look at number 5, it's kind of out of order. I messed up on my copies. So if you turn it over and you look on the 3rd page, number 5 is the one we're looking at. Okay? What I'd like you to do is turn to page 340 in your book, and we're going to look at some heats of combustion. So turn to page 340 in your book. So again, this would be number 5. You take the joules divided by grams, and you should get a number that's in the 20,000 range, maybe, or high teens. I don't know. You guys have to make that decision. What you came up with. High teens, low 20s, 20,000 range. So like in my example, if I came up with a change in temperature or number of joules that was like 14 or 1,400 joules, and then my change in my value of my weight was like 0.13 grams, that's what I would plug in. Yes, Adam?
What numbers do you plug up in
Number 3?
Yeah.
Did I go through number 3 or not? Did I? Okay. So you would plug in these numbers here. You plug in change in temperature of water, 4.184, and then your mass of your water. Yep, we're doing it off of this. So your mass of your water is 100 grams. Yep. Okay? Then what we're going to do is we're going to show how you would change that into kilojoules real quick. Okay? So let's say that that's my numbers, and I come up with an answer for that. And my answer is 10,800 rounded. So this is 10,800. joules per gram. So I want to change that to kilojoules. So how do I show that work of changing that to kilojoules? It's really easy. So I'll take my answer, you guys take your answer, not my answer. So 10,800 joules over 1 gram. Does anybody have an idea what unit will go down here if I want to convert joules to kilojoules? So what unit goes down here? Joules, good. And then what goes up above? I'm trying to find kilojoules per gram, so kilojoules. Does anybody know what numbers go with what there? Does 1,000 go with kilojoules to 1 joule, or does it go 1,000 joules for every 1 kilojoule? What do you think? 1,000 joules for every kilojoule. You are correct. So we're going to take that number, basically divide it out, and we have kilojoules per gram now. So that would be 10,800 in my example. No, I'm sorry. It'd be 10.8 kilojoules per gram. Okay, so show that on the next step. Is that, what did you guys come up, you guys share your answers with me if you would. What did you guys come up with for kilojoules per gram? Yep.
6.606.
What'd you get?
6.606.
So 6 kilojoules per gram. I'm just going to round it. Anybody else?
5.46.
What'd you get?
5.46.
5.46, so we'll say 5.5. Anybody else? No, did you get an answer? No, how come? You don't get what? You don't know what we're doing? You need to ask. There's somebody you don't know what we're doing, you need to back me up so I can help you out. Zach, did you get an answer?
No, because we didn't get
You didn't get your what?
the water temperatures.
You don't have the water temperature? Oh, you need it off your other sheet, probably?
Yeah.
Does anybody need those numbers off that other? So what we calculated is kilojoules per gram. Now we're going to go kilojoules per mole. So here's how you do it. All right? There's 352 grams in a mole. For, if I go C25H52, and we add that all up, we go, okay, at 25 carbons times 12, the weight of that is 300, basically 300.25. Okay, and we take the 52 hydrogens, that would be 52.52. So that comes out to be, what, 0.77, 352.77, right? That's how many grams are in a mole. So if I burn 1 mole of molecules, I burn 352.77 grams. Okay, so let me take my answer I came up with in the problem, which is different than yours. But my answer was 10.8, and this is what I'm going to do. I'm going to go 10.8, okay, kilojoules per gram. One more conversion. What unit goes up here? Up above? Grams, good. Okay, and then down below, moles. So what numbers go in those two spots? So 352.77 grams. I'm just going to round that to 353. So there's 353 grams for every 1 mole. I'm going to get a big number. So then multiply it out and see what you get. Then I want you to look at that last column in your book to see what's going on. If that's a realistic number based upon the numbers in our book. The numbers in our book goes methane is 890, and it goes all the way up to 6,300. The longer the carbons, the more carbons and hydrogens you're burning, you should have bigger heat of combustion per mole. Okay? So somebody that had 6 as an answer, okay? You take that 6 and multiply it times 353, because that's how many grams are in a mole. And you would get an answer that would be 2,178 kilojoules per mole. If you had an answer of 5.5 times 353, your answer would be 19,042 kilojoules per mole. And if you had the 32, you'd end up with 11,296 kilojoules per mole. Okay? So, make sure you're showing real good detail like I'm showing up here. I'll show it again so that on Wednesday when you have to do a lab, you can do that.